All right, guys, sorry for being late. Yeah, there was a little bit of internet issue here from my end. I hope that you guys can hear me. Okay, let me know. Type something up on the chat so I know. Okay, so as usual, what we'll be doing first is to go over the announcements. Hi, good. You guys hear me? Great, thank you. Good, thanks. All right, so the first two announcements, first bullets are these. As usual, the links for the live YouTube session as well as the Google Meet session. What's new this week is that, hey, we do have 4 assignments you're supposed to turn in or complete by Saturday, 6 p.m. The first is PA1. Yeah, the first programming assignment is doing. And then this week we also have 3 quizzes, okay, and they will pop up in the middle of the lectures this week. Now, something a little bit special is this, quiz number 3. Yeah, for many of you, you've already completed quiz number 3, but we do have a few students joining the second week. And these students have completed quiz 1 and 2. Okay, and quiz 3 was not required. So new students, okay, if you see that you're assigned an add code, make sure that you complete quiz 3 by this Saturday, 6 p.m. Thank you. Hi. And we have a special announcement today. Okay, guys, the class is full. We started a little bit slow, but it actually ramps up really quick. So all 30 slots are filled. Okay, as a result, Polly can post the add codes a little bit earlier this semester. Hi. Oh, okay. We see many other people popping in. Okay, welcome. So you see the add codes are here. So if you see the, if you go down the column on the right, those are the student ID. Find your student ID, okay, and take the code to the left of your student ID, and that should allow you to add to the course. Okay, be careful not to mistaken someone else's add code, because that will prevent the other student from registering. Okay. All right, and let's spend a little bit time to getting to PA1. The channel PA1. Yeah. So you see from channel PA1, because this is particularly important for the new students. Yeah. Your user accounts are all ready. Okay, and this is the username, and there's a default password. Okay, and you use this default password to log in first. And you want to change it as soon as you can to another one so that it's not easy to log into your account. Okay. And how do you know your team number? Yeah, so check out Polly's response to your answer in the quiz 2 channel. All right. Okay, and if you scroll down a little bit, you see, oh, Ash is asking something, and this is about PA1. Guys, Ash obviously read this note carefully. On the left, you will see this welcome and rules, and all of you should have seen this as you are invited to the Discord. Okay, I actually mentioned that individual channels are serving individual purposes. A lot of times, the discussion, when it's more focused, then it will be more effective. So PA129 channels are for discussions about or Q&A about PA1, PA2, specifically to PA9. Therefore, you have also exam channels allowing you to ask about exams. Now, when things that are a little bit out of each of these categories, then of course you use Ask Us Anything. Okay. So PA1, oh, I see that there's a question about PA2, great. Okay, great to see you guys starting work early. Because at the beginning of the semester, it's usually the lightest, and you want to do more so that you save some time to prevent assignments and exams coming up all at the same time in the middle or at the end of the semester. That's horrible, lots of stress. And you normally can perform well, but under the stress, your productivity is usually 60-70%. And so Ash asked a question. So she has already completed PA1, and she was worried whether just one of the members is required to complete PA1 on behalf of the team. Yes, from Polly's point of view, as long as all of you submit one answer is okay. It's just like the quizzes. So PAs are just like the quizzes. One member complete on behalf of the team. That is sufficient to earn the grades for each of the parts. But it is advised that all of you exercise, okay? Because these quiz questions, these PA assignments, Polly might ask you to do some programming in the exam. And you know that programming is something that if you are not familiar, in order to come up with the solution you had in mind, it will take a long time. Okay? And it's not going to be possible during the exam. So you do want to exercise and make sure that you are familiar with the syntax. Okay? So do exercise. But the thing is this. Okay? The other team members, if they work on the same directory, PA1, PA2, then their work might override other members' work, right? That's not good. So what do? Under the PA1, the students not in charge of submitting the solutions can create subdirectories, and you work under that subdirectories under PA1. See? So you isolate your work from the work that is supposed to be submitted. Okay. So the best practice for teamwork like this is this. So you might assign one student as the member in charge for a PA or for a quiz. When the student is done, you send a message to everyone, every other member saying that I'm done. Guys, double check. And the other team members double check, make sure things are okay, and reply to the member in charge. So that eases the nerve. Okay, and you guys will be happy to move on to the next PA, to the next quiz. All right, good. So this is PA, and you see also Polly posted something. Because Polly discovered that your username and the real name, okay, are inconsistent. So Polly was trying to fix that yesterday, okay, and Polly managed to fix that, but neglected to modify the firewall setting, and that is why we had another thread of discussion going on in the Ask Us Anything channel. So if you go to this channel, you might see that there's a little bit of traffic here. Okay, for example. Let me scroll up a little bit more. Justin here was asking, because PA1 is due this week, right? So Justin obviously wants to start early, which is great. But where are the PA assignments? Yeah, so Polly flash through the through this upper right window here with the golden there, with Gopher there. Yeah, it's this link, the golden link here. If you click in there, you see each quiz's PDF and the walkthrough video. And guys, before you ask anything about the PAs, go through the PDF file first and go through the walkthrough videos first. Okay. It's not something that you are left alone to work on. The PA walkthrough videos are there to help you exactly when you run into problems. So hopefully it provides a sort of self-learned experience. Okay. Nowadays, people put on what they know on YouTube. Maybe you can also search, okay, when you run into problems. And there might be someone posting something, and you just follow, and you figure out, okay, so you might just miss the flag here, there, and somebody else provided the answer already. All right. So take the PAs as an opportunity to self-learn. But of course, if you have system issues, logging onto workstations and something like that, definitely let Polly know. Okay. So Jeremy here, this is a very good demonstration of you guys helping each other. Okay, so click on the golden link and you'll get there. So Jeremy here, this comment earns 2 points for participation because it's beneficial to all students in the class. And Jiabao is from NTUST. I think that's Lei Jiabao. I hope I pronounce your name correct. That's a neighboring university. So NTU, NTUST, as well as NTNU. We are actually a university alliance. So there will be students attending classes from NTUST and potentially NTNU as well. So he's from that university. And he's having an issue getting an account to access NTU's VPN service. Okay, so it is a requirement to get an NTU account in order to get NTU VPN service. So I think I replied here. Yeah, your case is unusual, and this is the first time I do have a student coming from the Alliance University. Okay, so I'll have to. What did I say? Oh, I asked first what the NTU cool account looked like, and it turned out that it's a NTU ST email account. That means you don't have an account at NTU, Jiabao. So, hey, I have to cross-check with the NTU's computing center and see that if they can allow an NTU ST account or your account to register for VPN access. Okay. And then we see what? Okay, so Jin Tao is asking, how do we change the password? Hey, Polly is cool in a way that I know you're gonna ask that, and it's answered in PA1 PDF. Okay, so check that out, Jin Tao. Interesting. Heidi, Zhiyu, and Lu had trouble logging in this morning. You know what? Why? It's because Polly changed the username, okay, so that it's consistent with your real name. And how do I know? Thank you, Lu, for showing the screenshot, including the error message. Okay, that allows me to debug the situation better. Okay, when you say I couldn't connect, hey, there could be many reasons why you cannot connect. Okay, if you show me exactly how it's not connecting, much better, much easier for me to debug. So guys, you also want to also learn how to interpret these error messages, or it does not appear to be an error message, it's just so connection closed. You are not getting where you want to go to. But you see, you can actually copy and paste the outcome of what you're trying on the internet, on ChatGPT, for example, or just just do Google, okay, of that outcome. You might find many people have run into the same situation, and just walk through some of these solutions. You might just find a way to fix it. But hey, Lu and Heidi, in this case, only Polly can fix it. Okay, and Polly figured it out and then fixed it. And that's at the bottom. But let me just say that, hey, Yirsa and Ash are trying to help. This is great. Thank you. Even though that you guys helping a way that might not be solving the problem, but hey, this is actually very important. Showing support that makes learning a lot easier. So I think, yeah, here's what Polly explained, what the situation Lu and Heidi ran into. Ash and Yirsa, they were not exactly like what you guys have run into. All right, good. So we can now begin the topics today. So first, I call it topic 0 because it's to recap chapter 1.1. That was what we talked about last week. Okay, so it's a very high level overview of the internet. Right? We have end systems, we have routers, these hardware components, and you heard also protocols, the soft components. You heard also that from the very last quiz last week, humans also have communication protocols, and they can be very complex in a way that there seems to be a very big gray area as to how we initiate a communication or react to a communication. Okay, so you know what? Computer network protocols, they can also be complex, but they're complex in a very different way. There could be lots of rules, and the rules are strict. But at any given situation, there's only one way of reacting. Okay, so human protocol, computer protocol, both complex but very differently. So that's very high-level internet. And we go on with the first serious topic today, INET Edge. Okay, this is a slightly more detailed overview, but focus on the internet edge. In this first video, you will hear about the components we have on the edge of the internet, particularly the end systems. You will also hear that the end systems communicate, and they communicate typically in two models. This video, about 3.5 minutes. Let's take a closer look into each of the components, and starting from the edge. So essentially, we have lots of these end systems running applications at the edge. Two very dominant examples, web and email. So for example, this guy here, a laptop. This guy here, a server. Okay, usually server are higher end machines having more computation power or higher amount of storage. So web browser will be talking to a web server requesting for a web page. Okay, so that is called client-server model application, where the client requests for services and receive services from the server. And you see that the expectation of these servers are that they run all the time, 24/7. And that's why these servers need to be higher end machines having more computation power, having higher amount of storage, and have more reliable internet connection. Okay, so as we mentioned, web browser here, web server here. Now, some of the pairs could be running email. Then you have email client, which is typically the email reader, and then there'll be email server. So these email servers usually you don't get your hands on. Okay, you don't see them. Just like the web server, you don't typically see a machine. Okay, physically that is a web server. There's another way of communicating the end systems, the applications running on the end system, that is called the peer-to-peer model. Okay. The idea there is to get away without this, always on server. Now, imagine, right? Setting up a web server yourself and allowing thousands and maybe millions of clients in the world to access your web server. You do need a lot of money, right, to maintain it. But some applications might be more grassroots effort, where you don't want to be able to afford servers, and yet you still want to be able to exchange data. Yeah, that is what the designers of these peer-to-peer applications are thinking. Let's minimize the use of high-end dedicated servers. And instead, why don't we, right, smartphone, laptops, desktops, laptops, just, connect directly as peers, one to another. So there do exist several of these peer-to-peer applications. Skype is one example. BitTorrent, I'm sure that some of you have used it before, is a very dominant example. It's still very popular now. And besides these two, there's one example that you might go, oh yeah, that's right. It's called the Bitcoin, or cybercurrency. So that blockchain allowing the cybercurrencies to track itself is a peer-to-peer network. So there's no particular server. That is the whole idea of having these virtual currencies. Okay, instead of having a central bank to overlook everything, to track, record everything, to monitor any of the currency exchange, virtual currency, Bitcoins, it's completely distributed. It's peer-to-peer. All right, so client server, peer-peer. Based on what you heard, okay, take a pick. Which one would you prefer? Okay, if you are building a service, would you like your end systems to communicate in this client server model or peer-to-peer model? Okay, type it down on the YouTube chat, let me know. And then we move on to the second video, It's about the access network. Access network is this component in between what? The end systems and the core of the internet. Okay. This video overview of access net, only about 2 minutes. Now let's move a little bit inward and talk about the next component, access networks. We know by now access nets are there to connect the end systems to the edge routers. What we haven't talked about are that there are several of these access net technologies. In fact, in the next few slides, Polly is going to talk about 5 of these. And depending on where they are used more often, they are classified into these 3 categories: residential, institutional, and mobile. Residential meant home access. So some of these access net technologies are used more at home, deploy more for home environment. Some of these are used more for institutions such as NTU. And some are wireless, okay, so people can still access internet as they're on the run. For example, 4G is a mobile access network. Now, as Polly gets into the details and talk about each of these access net technology, try to pay attention to the bandwidth each of these technologies promises. Some of them offer higher amount of bandwidth, some lower amount, and some offers symmetric amount of bandwidth between downlink and uplink, but some offers more downlink and less uplink. Pay attention also to how the access net is being used among the users. Some access nets give you this amount of bandwidth, but all the users accessing the network will share the bandwidth. So if there are more users, each one gets a smaller cut. But some technologies actually, offer big bandwidth, and that access net will actually allocate a specific amount to each of the users. So each of the users will be guaranteed a specific amount, which is dedicated, okay? And if there are more users, none of the existing users will suffer. All right, good. So that was an overview of the access net. The next topic is to introduce 5 access network technologies. Okay, so some of them are for the residential access, some of them are used more for the institutional access. And particularly the last one, wireless access network, is for mobile access. Okay, so for each of these access network technology, Polly will talk a lot more about. This is actually where we'll be spending much of the time today. Okay, for each technology, pay attention. How much bandwidth, okay, meaning how much data we could download, upload per unit time, okay, for each of the access network technology. And you want to also care about whether that amount of bandwidth offered by the technology, do I have the dedicated use of that bandwidth? Or am I sharing that with many other people in my neighborhood? Okay. So even though one technology offers a high amount, if I'm sharing it with like 10, 20 other people, it might not be better with another technology offering a lower amount but dedicated. You see? It's a little bit tricky. Okay. Good. And I see that you guys are typing up your opinions. I can also see that the internet situation seems to be a little bit laggy than usual today. It might be part of the reason that Polly had the issue to start the stream today. But Polly also detected that there might be an IP address conflict from my end as well. So it took me a while to try to find a safe IP address and reconfigure so that I am able to connect. And I hope that it will work well the rest of the class. Okay? Yeah, some of you say depending on the application, depending on the services. And some just say that I prefer a P2P because I don't have that much resource or money to maintain a server. Okay. Now, let's go ahead and start with the first access network technology called ADSL, or sometimes called DSL. Okay. This one is going extinct. Okay. This video is also a little bit long because Polly would like to take it slow and make sure that things are very clear at the beginning of the semester. so it's easier for you to follow. Later on, Polly will definitely pick the speed up, but you will see that in some of the videos, Polly talk really, really fast, okay? But it might not be a good thing that I do that right now at the beginning. So in ADSL videos, pay attention. How much throughput ADSL offers? And is it dedicated or shared? 6 minutes coming up. The first technology is called the DSL, Digital Subscriber Line. This is pretty much a legacy technology, which is building on top of yet another almost legacy technology called the telephone network. So let me draw your attention to the example at the top. Yeah, where the telephone network is, starting from here, the phone set, okay, where you make a phone call. So the signal is going to travel through the phone wire to the hub on the wall. There are lots of also wires behind the wall, connect you through the central hub in the building and then out on the streets. And there are quite a few cables buried underground, especially for Taipei City. And those cables take the phone calls to the central office. And inside the telephone company, there are these switches. They're switching the phone calls. And eventually the phone call reaches a friend that you're calling to. So this is the telephone infrastructure. And it has been there since, I think, late 19th century. But starting, I think, late 20th centuries, we want to do this. Okay, generating emails from our home PC and send that to a friend somewhere else, okay, connected also to the internet. Now, to allow this phone PC, a home PC, to connect to the internet, we borrow the telephone infrastructure, particularly the cables and the wires we have in the buildings under the street, so that we could send the data somehow to the central office of the data network providers here. And the way it works is this. Let's assume we're sending an email to a friend. So that email is going to go and reach the DSL modem first. So DSL is the name of the technology. Modem here is actually modulator and demodulator. Okay, the first few letters combined. So what it does is, hey, email coming from your PC is in digital form. It's going to be converted to the analog form, so it can go on this cable here and multiplex potentially with analog phone calls coming from the phone set. So these together can travel the cables and reach the central office of the service provider. And by the way, very oftentimes the telephone service provider is also an internet service provider. Now, once they reach the central office, this big box, DSLAM, it's DSL, I think access multiplexer, okay, whatever it's called. What the functionality of this yellow box is simply, first, split the analog signals. Some of those could be analog voice for the telephone network. It will go on this way. Some of those are for the internet. It will go on the other way. And before this analog signal can go out to the edge server, DSLAM also demodulate the signal from analog back to digital so that it can travel the digital data network. You can imagine vice versa. Your friends send an email back through the edge router and reach the big yellow box, and that email gets converted to the analog form and multiplex with the phone calls together, traveling the cable, and finally reaching the household. First, go through the splitter. If it's phone call, go this way. If it's internet data, go this way. Now, at this point, the internet data is still in analog form, so modem here demodulate from analog signal to digital, and therefore you get to read your friend's response. Now, if you think a little bit more about the yellow box, what it does is essentially what the blue and the green box are doing combined. Modulating and demodulating. Multiplexing and demultiplexing. What is a little bit tricky there is so that how do we do the modulation right, and how do we do the multiplexing so that the voice and the digital data will not interfere with each other. And that is done and achieved by, by splitting the frequencies of the EM carriers. So what we're how we are sending data or in analog or digital form is that we are modulating these signals onto the EM wave carriers. So we modulate the analog voice to this frequency band of the carriers, and upstream data to this frequency band, downstream data to this frequency band. And they are mutually exclusive, therefore they won't be interfering with each other. Okay, so phone is going through the 0 to 4K hertz frequency band, and upstream data 4K to 50K hertz, downstream data 50K hertz to 1 megahertz. So you see that the downstream data is using a wider frequency band, and so not surprising, upstream bandwidth only 1 megabits per second, and downstream we get 8 megabits per second. The last about DSL is this link here. Yeah, this is one link per household. This is very dedicated, okay, between the central office to the user. All right, so that was ADSL. It's quite straightforward. We just have two converters, digital to analog, and then analog back to digital, and the other direction as well. And you see that the bandwidth is about a few megabits per second. That's low, right, for today. And that's why it's going extinct. It's not going to sustain the user demand these days. And so we have the next two generations of access networks, cable and FTTH. We'll start by cable, okay, cable network. Okay, it's the next generation, and once again, pay attention to the bandwidth it offers and whether it's dedicated or shared. We know ADSL is dedicated, not bad, right? Is cable dedicated or shared? This video is also about 6 minutes. And the second access net is cable modem. A little bit similar to DSL, it's also for residential access. And unlike DSL, which is exploiting the telephone infrastructure, cable modem there uses the cable TV infrastructure. Yeah, you see, we also have lots of wires behind the walls leading to a central office, leading to the cable company. That's how we receive the TV programs. So, cable modem here, exploit that existing infrastructure. What's nice about the cable modem is this. The bandwidth available, it's also asymmetric, where you see the downstream bandwidth and the uplink bandwidth different. In cable modem, wow, lots of downstream bandwidth, 30 megabits per second, but very limited upstream bandwidth, only 2 megabits per second. If you judge based on only the amount of downlink and uplink bandwidth from cable modem and compare it to DSL, you'll see, whoa, cable modem wins, obviously. Yeah, for DSL, this is only 8, and this is only 1. But you want to be careful, though. These cable fibers attaching household to the cable company, they are shared access links. Unlike DSL, these telephone wires are dedicated access. That is saying, oftentimes a cable company will set big cables, center cables from the center office to a neighborhood. And there's going to be a splitter that splits TV programs and across hundreds and maybe thousands of households. Yeah, if you use cable modem, sending data, your data and all your neighbors' data will be multiplexed on that cable and to the central office. That cable there is not dedicated, it's shared. So even though the bandwidth is higher, but you can, be competing potentially with all your neighbors. And it really depends on how many people are subscribing to the cable modem service in your neighborhood. That determines really the quality of your internet access. To illustrate, let me show you this example where we're connecting hundreds and thousands of households together through one major pipe to the cable company. And inside the cable company, you see often lots of these video servers, and stored on these video servers are the TV programs. So the cable head will stream these videos down this way. gets split it here, 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 here. Okay, depending on what each of the household is requesting. Okay. Occasionally also from the household, there could be some control messages being sent, for example, to switch channels, okay? For example, to turn the TV program off. Now, if you have the cable modem installed at home, the infrastructure is going to look a little bit more extended, but most of the extensions are inside the household, as well as in the central office of the cable company. Yeah, I know, if you look at this picture here, you see, very familiar, right? Just like DSL. If there's signal coming in, the splitter here will check. If it's TV program, it will go on this way. If it's data, internet data, it will go on this way. And the cable modem will convert it to the format that's readable from our PC, and therefore you read the message from your friend. And similarly going out the other way, right? So your message will go out from the household and through the shared pipeline to the cable company. And inside the cable company, there is this big multiplexer and modulator that's doing the right thing so that your internet data goes on to the rest of the internet. Okay. And your friend sees your message. Now, be careful here. There's only one cable here. If there are messages coming from this other household or this other household, they will all get merged onto this cable. Now, these messages coming from the household, they will share the same channel and compete for the bandwidth there, unfortunately. Another thing that you might find surprisingly similar between cable and DSL is this: how we are multiplexing the original infrastructure networks data as well as internet data. And this is how cable modem is doing it. These first few channels are video, data, and last one, control. The channel towards the left, lower frequency. The channel towards right, higher frequency. So essentially what you're seeing is that the entire frequency band allowed on a cable network are divided into some subbands. Okay, so 1 to 6 are for videos, which are the TV programs. 7A, in this example, are for the internet data. And then these control messages, such as switching to a different channel to a different TV program, is only just one subband, right? And so they kind of run on frequency subbands that are not overlapping, completely separated, so that they would not be interfering with each other. Okay? So that technique is formally called frequency division multiplexing. Okay? So we kind of cut the entire frequency band into non-overlapping subbands, division over frequency, hence the name. Okay, so now you see that there are some similarity between cable and ADSL, right? You begin to see, hey, there's downlink bandwidth and uplink or upstream bandwidth. Okay, what do these two terms mean? What do you mean downstream? What do you mean upstream? Yeah, consider the ISP, okay, the cable company or the ADSL company higher up. So to draw data from the company, that's downstream. And the maximum amount we can draw from the cable company or DSL company is the downstream bandwidth or downlink bandwidth. And the other way, uplink or upstream. Okay. So you see that, hey, data going two different directions. The maximum amount allowed are different. And that's why they are asymmetric. So DSL is digital subscriber line, and ADSL is exactly asymmetric DSL. Okay, so that is to describe that hey, the amount of data you can draw down versus push up, different. And this has something to do with how we access data on the internet. A lot of time we just download. We don't send all that much data out. Okay, so ADSL cable, they share us, they are simulating a way that the downlink uplink bandwidths are asymmetric. Second, what you hear is also that the reason that we can send digital data over from one machine to another machine is because we actually modulate these 0 and 1s, the digital bits, onto electromagnetic waves. And what we are really propagating over the space or cable are these electromagnetic waves. So that is saying that we're embedding these 0 and 1s on the electromagnetic waves, which can come in different frequencies. And this actually explains also why downlink uplink bandwidths are different. It's also natural when you assign 0 and 1 bits to a particular frequency, you can potentially modulate more bits. In some other frequencies, lower amount of bits. All right, so different frequencies allocated, different frequency bands allocated for different purposes. All right, so ADSL cable, and you see in cable, the amount of bandwidth, especially down low, it's tens of megabits, much higher. But cable is actually shared media. So you might be sharing that tens of megabits with 10 households or maybe 20 households. In that case, it might not do better. And that's why we have FTTH, which is dedicated and also high bandwidth. And this video is actually 5 minutes, which is longer than the time we have remaining. So what Polly will do is to clarify something. Okay, if you come back to the chat here. Yeah, so many of you express your likes of peer-to-peer system. Cool, right? Treating everybody equal, and you don't need to build a server, which you might need to purchase another machine. And to be a server, you might need to buy bigger disk, install extra software, which is tiring and costs more money. So P2P, I can totally understand. And some of you say that you prefer the other model, and saying that I prefer the end system model. Okay, you know what, guys? End system is a term that's to describe all these devices we see, okay, at the edge of the internet. So, for example, computers, desktops, smartphones. Okay, as long as they are connected to the network. That includes also servers, bigger machines, servers connected to the internet. Servers are still at the edge of the internet. Okay, it's not actually in the core, even though server sounds, oh, it's important. Okay, it's higher end, okay, it's somewhat authoritative, but they are still at the edge of the internet. And all these are end systems. So end system is a very general term, okay? For these end systems to communicate, two communication models. One is P2P, so each of these systems are treated equal. The other is what? Client server. I think you guys who said that you prefer end system, I think you probably meant the client server model, where there's a machine reliable and operating 24 hours a day, 7 days a week. Okay, so client server is the opposite of P2P. Okay, and both of these, P2P and client server, are the communication models one can apply to allow end systems to send messages to each other. Okay, I hope that is clear. And you know what, it's 2:09, so we'll actually end the lecture today here and continue to talk about FTTH, Ethernet wireless, and quiz 4 is actually coming right up after 4 videos. All right, so if you have further questions, feel free to type up on the chat or type up on the Ask Us Anything. Good. With that said, I say goodbye. I see you tomorrow. Okay. And sorry for the glitches earlier today. Polly's ending the stream now. Okay, see you tomorrow.